Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Computer Wednesday, we're going to talk about NVIDIA DGX Spark. So let's dive deep into it. So this DGX is NVIDIA's attempt to basically shrink all their offerings into three-letter words. Basically, how we used to have GTX, and now we have RTX. Same is DGX. Now DGX is a short form of their official lineup, which was DIGITS, digits, which actually had a full form, which was Deep Learning GPU Intelligence Training System. So we just call it DGX. Now we know. So DGX. Now what is this? Basically, this is a purpose-built AI supercomputer. Now, one thing you have to understand, supercomputer are a relative term, so to say. So for example, the smartphone that you have right now, if you go into Apollo era, that's a freaking supercomputer. Like you have to wait till quite long time before your normal average smartphone that was made in year 2025 would be overtaken. Like you have to wait a while, like decades of supercomputers have to be built and then dethroned. Then they will have some supercomputer that will finally beat your performance. So this is one thing you must understand. Supercomputers are never just a thing. It's always in relation to what is available. For example, if you have 10,000 exaflop, and if someone has 11,000, they become the supercomputer or the best supercomputer. So generally there is a cutoff point where it's like below this is just average server. We do not count as supercomputer. So supercomputer is always a relative system. So NVIDIA does have the ability to make the world's largest supercomputer. They do provide parts for this. So all these things, or basically the DGX lineup, is a part of a supercomputer. You have to buy a bunkersly large amount of them and combine them into a unit and then call it a supercomputer. That's a technical supercomputer. This is just marketing to calling this thing a supercomputer. It's not. Is it good? Yes, absolutely, definitely. Is this a supercomputer? Go back far enough in time, yes. But again, not a technical supercomputer. This is a part of a supercomputer. You have to take multiple of these puppies, then you can be like, yeah, now we actually have a supercomputer of top 500 or let's say at least top 1000. So fundamentally, do not get that part confused. It's a part of a supercomputer, not the supercomputer itself. They do call it, because again, marketing, but it's not a supercomputer. And what NVIDIA is pivoting to is basically going from, because they have given all gaming, they're like, yeah, it's a cool and all that, but again, it does not print money. So they want to print money. So to print money, they want to remove a lot of hassle. And you have to understand this one aspect very seriously. In enterprise environment or corporate environment, or basically when you have dealing with some serious money, people will pay 2x or 5x or even 10x the price, or the a genuine price, if you can remove their headaches. Meaning, can people build their bare metal servers? Absolutely. Then why would they pay, again, higher cost, especially over a long period of time? Why would they pay a higher amount of money for, let's say, Amazon Web Services? Because Amazon Web Services takes their headaches away. And NVIDIA noticed this trend that people will willingly pay money if you can take their headache away. So they are like, okay, we are pivoting from a hardware provider to a provider of an end-to-end solution, meaning companies should come to them. It's like, we have this requirement, go. And NVIDIA is like, I got you, fam. So NVIDIA will pick up the phone and figure out how to get the parts that you need, rather than you going to hey, MSI or let's say Microsystem or what else would be there? Dell, all of the HP, all of these companies, and then them assembling the system. No, they want to be like, okay, let us worry about it, aka NVIDIA worry about it. You go to NVIDIA to talk to them. So to provide end-to-end solution for any and all AI workload. Which basically NVIDIA is the daddy at this point in time. And again, even if it is double the price, for example, let's say Dell's offering or HP's offering, people will willingly pay for it as long as NVIDIA can remove the headaches. Thou shall not have headache. People will pay for less headache-free experience. So to do that, they have to do multi-prong attack, meaning you want to do this, that means nothing. That's like why Microsoft is garbage in terms of operating system. Apple understands this part. It's about experience. It's about removing the headaches. Why did ARM did not make Windows great? Because Qualcomm did not understand that you're supposed to make dev kits and you're supposed to flood the market with dev kits so people can develop it, fine-tune it. Then you're supposed to launch the hardware. Not like, who cares about the dev kit? NVIDIA learned from there. This is a dev kit of this ecosystem. So before the ecosystem becomes a full-fledged things, It's like, hey, let's just get everybody into the pipeline. It's almost like how Autodesk made Macs very easily available, very low cost in the early days. So people, once the students are used to 3ds Max, they will go into industry. People, even though industry would be using Maya, they will be like, can we use Max? And people will just buy it. Headache-free experience. So pivoting to end-to-end system requires that sort of long-term planning. You cannot just go, tada, now buy us for, no, you have to plan it. Like you have to have a dev kit and all that. So DGX is the whole lineup for every scale. Let that be very clear. So you have the smallest dev kit for normal people. You have a workstation grade, which is like for serious heavy loading or like a lot of multi-user scenario. And then you have this, which is like, tada. So DGX is that whole product SKU. And when we are talking about DGX Spark, we are talking about the smallest dev kit that is available. And this is for people who wanting to get into AI. This is not a computer that can do AI development. This is an AI development that is packaged as a desktop. Let that be very clear. So if you compare this to, let's say, Frameworks desktop, Framework desktop is a desktop first. It can do a little bit of AI. This is AI first. It looks like a desktop. And it has the same hardware core as the current flagship at this point in time, as in year 2025. So it has the same hardware that is around the world in hyperclusters working right now. So that's the part, meaning you do not have to like, okay, does it work in this topology? Will it work in the like actual hyperclusters? Absolutely. Why? Because most hyperclusters are utilizing NVIDIA's equipment, and the latest you have already trained for it. Again, NVIDIA is actually planning ahead this time. So, and it is powerful enough because again, they have enough of a system RAM that it can actually unload a ginormous amount of LLM into it, like parameter wise, like more than enough. And like how much more? Well, simplified this way, one engineer put it quite eloquently. It's just that if you are only feeding one user, this will be no different than running it on a hypercluster. Because you might say, oh, wouldn't hypercluster require awesome, like, super giant 1 exaflop or something like that? Yes, for training, but for running, no. Whenever you are running, like let's say if I follow my prompt is virtualized. It's like a big pie. A small slice is given to me for every single prompt. That small slice is smaller than this. This puppy can directly handle a single user like there is no issue. It's like single user, I got this. I'm good. Be good. Got this. So if you're just like, hey, I want to have a system that is just next to me, very low latency, and again, sensitive data does require those sort of things sometimes. They're like, I got this. Single user, it is no different than current right now. Again, that's why I specified that supercomputer is a moving target. Few years from now, not even few years, I would say 3 years from now, this will be like barely enough for next iterations of system. 2.5, it should last 2.5, at least 2.5. Come on, at least 2.5. So it should last for that. And it has 1 petaflops of computation in a mini desktop format, this puppy. Now, how much is 1 petaflop? It does not really matter. It's like a number, meaningless number, like same way you have horsepower for cars and kilowatt for electrical motors. You have that. But again, there are so many other variables that go into this that is just a simple number. Supercomputer also have those numbers like 1 exaflop, 10 exaflop, 10,000 exaflop. So it's just a number. And it does have ARM CPU and latest Blackwell GPU with chip-to-chip connect, which Apple keeps yelling is like, we have connected. NVIDIA is like, bro, we have been doing that for years at this point in time. Like again, they did not make it a cheap kit, but again, they had the technology for surprisingly long amount of time. So this is the DGX Spark, a dev kit that is small, easy, and should train you enough into the ecosystem where you can just go at it. Now, what about the hardware? Now, this is where basically the marriage between two parties play a role. The marriage between NVIDIA and MediaTek. Now, be mindful, NVIDIA have been slowly acquiring some big puppies like Menelocks. And if you do not know about those companies, understand this way. That's how servers are connected. Not you and me, servers. And so basically, if you have to have two servers making love to each other like at hundreds of gigabits per second, you have to have some dedicated ASIC hardware and certain patents and certain technology that allows you to do that. Menelocks had that. NVIDIA is like, I got this. Directly, I got this. So this time they got this, MediaTek. Now be mindful, NVIDIA is a very hard partner to work with. Half of the GPU companies are like, yeah, it's not worth it. It might slowly let it go. And again, they had a feud with Apple so bad that Apple is like, we have a pro system. It's like, awesome, GG, Apple, smooth ecosystem. And instead of having NVIDIA Quadro, they had AMD. And like, why? they had an issue. Basically, what happens if you have two controlling people getting in bed together? It does not work out. So MediaTek, and again, I'm pretty sure that's why it's not Qualcomm. Qualcomm would have been like, no, I want to do like this. NVIDIA is like, I want to do like this. It would not have worked. And MediaTek is like, yeah, we are not the giant, but we have big enough footprint. Where in car, meaning right now your car is moving towards self-driving. That requires a ginormous amount of silicon. And again, that's why x86 is a problem. There is no x86 car hardwares, and almost all of them is ARM based. MediaTek wants to have that market cornered. To reach that goal, that dream, they have to have ARM system taken care of, plus a compute horsepower. Who has the best compute horsepower at this point in time? NVIDIA. So basically, MediaTek is like, we'll handle your sharp edges and you're gonna provide us the compute horsepower. So MediaTek and NVIDIA got in bed together and they pooped out this puppy. This has 20 cores for the CPU part, 20 ARM cores. So it has 10X925 cores. Those are powerful cores. And 10A725 cores, which again in contrast looks like a low power efficiency core. Now, does that matter? Well, here's the deal. Right now, way too many servers are not running on x86, way too many of them. Like Amazon Web Service literally has their own silicon lineup. So this ARM system for a server-based equipment is like, yeah, older news. So that's a good thing. Having 20 cores has more than enough oomph, more than enough latitude, and enough VRAM and SRAM, system RAM and video RAM, that they can handle it. And because it has chip interconnect, it's connected with Blackwell core, that it does not have the topology issue that Windows suffers from. There is a topological issue where it's like, if you want to dump any data into VRAM, it has to go through system RAM. So basically your NVMe dumps data into RAM, RAM dumps it into CPU, CPU dumps it into PCI bus, PCI bus slowly floats it into the VRAM. Now it's a very tedious process, and you're like, nobody has figured out a better way? Yes, they did. It's called PS5. So where you directly take the data pipeline from basically NVMe and directly dump it into through PCI bus into the VRAM, because again, both of them are in PCI bus. So somebody figured it out. It's a software developer, like kernel level thing. It does require not hardware change, because if you have paid attention to modern hardware, they can support it. It's just that software, kernel and all that is not cooked enough yet. They have cooked the hardware also. So meaning the latency that will happen is minuscule, meaning it does not copy the data from, okay, I'm going to take the data from NVMe, dump it into system, then dump it into VRAM. No, it's like, goes there, interconnects, like, yo man, that data is for me. It's like, I got you fam, directly. So it's a very good efficient system. LPDDR5X, LP means low power, DDR5X is like turbocharged variant, so to say, and they do not have to worry about system RAM or VRAM, because again, that chip interconnects makes everything very efficient. Data goes where it needs to go. And NVIDIA Connect X7 networking. Now you might be like, okay, this shows the silicon, this shows the network chip, this shows the power rail, that shows the USB. What the hell is this puppy? Well, this is when I said that they bought Menalox, is this puppy. So this puppy is Connect X7. Now, whenever you have this sort of servers, how the heck server communicate with each other? Well, they have their own dedicated QSF ports. These puppies, those giant rectangle things. That rectangle thing requires ginormous interconnects, and that ginormous interconnect requires ginormous ASICs, application specific integrated circuit. This puppy. So this puppy is ConnectX. That puppy is rated for 400 Gbps, meaning if you go into enterprise grade hardware, many times they will have like, you know, a giant switch gear, and it's like it's rated for 400 Gbps. Yeah, that silicon. So meaning it can easily handle 200 in and 200 out without any issue. And that's why two of them are, so you can daisy chain few of them without any issue. So again, it's a flat out flexing at this point in time. It's like, yeah. And again, this should help you understand, like, this is not a computer that is acting like an AI system. It's an AI system first. Like, they took a server and miniaturized it. That's why this whole section is just server. Oh, they have RJ45 port just in case if you are poor and you have 10 Gbps internet. That's for poor people, rich people. So that's there. 200 GB, basically from cluster to cluster. That's why like they can daisy chain it for you. You can buy a pair, they will give you that direct attached copper cable, and you can just have fun with this. Now, one thing I do like about Apple designs is like, if they're like, hey, this thing cannot work without AC current, why not put the converter, basically AC to DC converter, into the damn thing? I like that part about Apple. Here it's like, no, what if we have power adapter? I was like, it's a small thing. It's like, bro, show the adapter. It requires upwards of 170 watt, and I'm pretty sure half of it is just for these puppies. And you can see the freaking coolers on this. Like, this puppy is heavy, expensive. Like, it requires fans on whenever you're talking about, like, enterprise grade hardware. So this is the most heat producing part. Again, that silicon is good. So 171, and fourth USB-C port that has a little lightning bolt that has the power delivery, and you can see that power delivery circuit there. And you're like, okay, how can you give 170 watt from USB-C? If you have old USB-C laptops charging, you must have seen they are only rated to 120 watts. Those are USB-C power delivery 3.0. You have now power distribution 3.1, which power distribution, power delivery 3.1, which goes up to 240 watts. So that puppy can give you 170 watts. So you do have to buy that super expensive. I think one company so far, Delta Electronics, have released that adapter that you can just plug on this and it's like, I got you. And I'm pretty sure that would be big. Like, even that Delta Electronics, it's big. It's big. Unless it's like gallium nitride based, then it can shrink a bit. Very high frequency, very high switching. Then you can be able to shrink it. But I'm like, just put it below it. Just make it a little bit bigger. Just like, I can't run it without it. It's not like I'm going to run it from a power bank. So I hate that design approach recently in PC, and this, I hate that approach. Like, this port is for the power and others are for what you call data and comms and all that. So that's the hardware part of it. Now again, hardware is nothing without a software. So think of these as more of like a dev kit. Basically, when I used to develop the games, like for Xbox Forza, I was like, okay, I made the asset. So how would my art director know that this asset will work? He will load it into a system. That system will sync it with a dev kit, like a physical hardware that we receive from Microsoft. That dev kit will verify that does it work or not. If it looks good, it works, done, go home, sweet dreams. So this is like that. So the software is also has to be tailor-made for that. So the idea is make this and use it if you have a single user only, meaning if you want to just run, not training, just to run the model, this is more than good enough for a single user. Because again, giant slice sliced into smaller section, this is a larger than those smaller section that you receive. So that's why it's actually useful. And again, given the fact that you can attach few of them and test out your basically tolerance, algorithms, error handling for a cluster system, that will also, and again, that's why they will pay that having 200 GPS interconnects pay off. So it can work perfectly on this, and then you can just push it onto a larger system, meaning you can take on this, once you verify everything, tada, it goes into this. This is like what they are selling to Google Cloud, Meta and Microsoft, and they have specified 256 Grace Hopper super chips and 144 terabytes of GPU memory, and NVLink is 230 terabyte per second and 1 exaflop. So basically this rack, I don't know, aisle, I think, yeah, that's the technical term, one aisle of this. So you test your puppy on this, it works, push it here, done, go home, sweet dreams. So what about happens from here to here? Well, all that issue would be NVIDIA's headache. You do not have to worry about it. Unless you are talking about that cluster thing, which again, NVIDIA does encourage. If you want to push from here to here, do push it from here to multiple of that, so you can test the cluster part of it. So they're gonna give you NVIDIA certified custom Linux distribution. Basically, it's Ubuntu. Again, be mindful that Monolox thing does require custom driver. That's why NVIDIA has to sit down and work on it to get it in a working condition. And they have worked with Docker and NVIDIA's container toolkit. Be mindful, same way Amazon has their own ecosystem, own hardware and old toolkit. This also has the same thing. They have software and hardware toolkit. So they are making sure that part is taken care of. And NVIDIA's AI enterprise suite validation, basically how you have Microsoft Office suite, almost every kind, like Adobe has a suite, Autodesk has a suite. Same way AI, NVIDIA's people have their own suite, and this hardware is verified for that. Meaning, if it works without any issue in this, without any errors, it should work flawlessly in this, or at least it should have minor issue. Basically, you should not be like, oh, I forgot a semicolon. That should not happen. So that's the whole point, and it's powerful enough for clustering also, because that's why that 200, one port is 200 GB. You can have 200 going in, 200 going out, because chip is 400 rated. So you can cluster it, and at that point in time, it's more than good enough. So for example, if you are doing something very sensitive, there are certain scenarios where it's like you cannot have a single line of this leaving the building. Heck, even our art assets did not go there. It's like we had our own, rather than uploading into GitHub, we had our own SVN, so to say, where we were loading everything. So many times you do require like that level of security. So if like, hey, what if I want to use AI to do testing and validation and all that? Okay, cool, buy this. That would be actually low cost enough where you can buy it, and then you can just like have a cluster of this. It's like it's a actual ready to go hardware that can help you. Basically, this could act as a good AI agent for you, which can just you can train for your hardware that is sensitive, that will never leave the building. As long as you can make sure somebody cannot steal this, you'd be good, you'd be fine. So the software stack is also taken care of, and that's why like people will willingly pay for this sort of system where it's like, thou shall not give me headache. Now, what about the ecosystem? This ecosystem, again, NVIDIA is in the early phase of it right now. Again, if this gamble pays off, anybody who bought NVIDIA stock right now would be swimming in money. So NVIDIA GPU, same way they have a founder edition which does not exist actually. This also does not exist. You're not gonna buy those things. They do not exist. Some pieces will be sold, but it do not exist. Same way other vendors will join up. At this point in time when I'm making this, there are 3 vendors. Dell Pro Max with GB10. Then we have Asus Accent GX10 AI supercomputer, and you have HP Nano AI Station ZGX. So these things are. Now be mindful, inside them the hardware is same. They do not like, it's not like a GPU where the PCB changes. No, the whole package goes from NVIDIA to these board partners, and then all they do is basically how they arrange the cooling of it and how they arrange the NVMe of it. Basically, NVIDIA will give you 1 terabyte for $3,000, and for 4 terabyte you have to pay $4,000. So there is a good chance that these things can be lower than the price, because again, they might be bulk buying it, so we do not know the profit margin and all that. And again, I do not think NVIDIA is planning to sell directly to customers. Again, it will have too many callbacks, warranty issue and all that, so they're like, hey, they'll take care of it. And but again, they do need to make sure that dev kits go into every household, everyone who is dealing with this. So when they go into the ecosystem or enterprise, they're like, hey, can you just install NVIDIA? Like, I'm familiar with this. We don't have time to waste. Just go. So Dell, HP, Asus, again, that's, I know there are other partners also which they hinted at, but again, I do not know where they are along. The hardwares were shown this. So all of them have same core, same board and RAM, and I do like the fact that they do not have RAM options. It's like, tada, take it and go. So again, that's why I said like, this is not a computer acting as a supercomputer, acting as an AI console, so to say. It is an AI console acting as a computer. And only NVMe and cooling. Again, none of them even had power brick into them. All of them, but to be fair, I can understand it because you have to do board-to-board power delivery. So this 4th port is that. I think NVIDIA one had 5th port. Anyway, if you find a high resolution, look into it. Which one has that? So that's there. So price-wise, it is expensive, but again, it's not meant for common people. Like again, if you look into the price of normal console versus the dev kit console, this will seem reasonable. And again, NVIDIA is learning from the mistakes of Qualcomm, where it's like, yeah, dev kit has to come first before you're like, hey, buy us. No, dev kit has to come first. And this idea of launching them with multiple partners to make sure, like some places, let's say Asus has a good market penetration, they're like, we got you. Some places Dell have good penetration, they got you. HP has remaining places, they got you. That's a good approach of making sure market penetration is the key. If dev kits get penetrated into market, they're good. So this was my presentation on this new era of DGX. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike. Press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free. And as always, thanks for watching.